In the following chemical energetics question, the question is related to Hess law, and the question states that the standard enthalpy changes of formation of iron 2 oxide FeO and aluminium oxide, which is Al2O3, are given as minus 266 kilojoules per mole and minus 1676 kilojoules per mole respectively. And you're asked what is the enthalpy change under standard conditions for the following reaction. So you need to find the enthalpy change for this particular reaction. So this is what is unknown, and what is given is you're given the enthalpy of formation of FeO and you're given the enthalpy of formation of Al2O3, and you're not provided the enthalpy of formation of Fe or aluminium. Now remember that elements have an enthalpy of formation which is 0 because you don't need to form elements. Aluminium, aluminium doesn't need to be formed, so its enthalpy of formation would be 0. So by default, we also know the enthalpy of formation of aluminium, which is 0, and we also know the enthalpy of formation of Fe, which is 0 as well. Now, if you know the enthalpy of formation of the products in a reaction and you know the enthalpy of formation of reactants in an equation, so you can use a simple formula of Hess law, which is that the enthalpy of a reaction is equal to the sum of the enthalpy of formation of products minus the sum of the enthalpy of formation of reactants. So that's what I'm going to do to find the enthalpy of this reaction. I'm going to sum up the enthalpy of formation of products and subtract the enthalpy of formation of reactants. So my products are, and I want the enthalpy of formation of my product, which is Al2O3. So for Al2O3, the enthalpy of formation is given as minus 1676 kilojoules per mole, and there's only one Al2O3, so minus 1676. And for Fe, the enthalpy of formation is 0. Elements have enthalpy of formation equal to 0. And minus my reactants. So enthalpy of formation of my reactants, for FeO, the enthalpy of formation is given as minus 266. But that would be multiplied by 3 because I have 3 iron oxides over here. And aluminium is 0. So that is 0. And I'm going to try and solve this now. So it's going to be minus 1676, and this minus and minus would become plus 266 times. It's going to be plus 266 times 3. I'm going to use my calculator to solve this now, and the answer that I'm getting on my calculator is minus 878 kilojoules per mole. So option B would be the correct option. So using the formula enthalpy of formation minus of products minus the enthalpy of formation of reactants, I was able to figure out the enthalpy of this particular reaction.